Assalamualaikum and hi everyone. This video is about section 6.3 linear function. A linear function is a function of the form fx equals to ax plus b, where a and b are real numbers and a cannot be 0. Means a linear function is a polynomial function with degree 1. We also can write a linear function as a linear equation in the form of y equals to mx plus c, where m represents the slope of the line or the gradient of the line and c is the y-intercept. This equation is also called as slope-intercept form or slope form, because we have information of slope and also y-intercept. The slope or gradient of a line that is passed through points P and Q is given by this formula. M equals to the difference of y elements divided by the difference of x element. We also can write a linear function in a point slope form, where the equation is written as this. We have slope and also information of coordinate of one point. Y minus y1 equals to m times x minus x1. We only need information of the slope of a line and also the coordinate of one point on the line. Okay, how to draw a graph of a linear function? First, we need to find the x-intercept and y-intercept points, the coordinate of these 2 points, and then we connect these 2 points by a straight line. Okay, now let's discuss example 6.6. Find the equation of the line through the given pair of points. Write it in slope-intercept form. Means we need to write in form of y equals to mx plus c, and then we need to sketch the graph. Okay, let's do the first one. Okay, what is the equation of a line that's passed through point P and Q? First, we find the slope of this line by using this formula. Okay, find the difference of y component. So let's say point Q minus point P. So 4 minus 3 divided by 2 minus negative 1. So we get 1 over 3. So this is the slope or the gradient of the line that passed through point P and Q. Now use any point. Let's say we select point Q and slope 1 over 3. Okay. By using the slope-intercept form, y equals to mx plus c, substitute y from the coordinate of point Q, which is 4, equals to 1 over 3 times x is 2 plus c. So we just need to find the value of c. So we can get c is equal to 4 minus 2 over 3, which is equals to 10 over 3. Now by using these two values, c and m, so we can get the equation. Okay, the equation of a line that passed through point P and Q is y equals to 1 over 3x plus 10 over 3. Okay, to draw a graph of this line, we need to find coordinate of y-intercept and x-intercept. So we already know the coordinate of y-intercept is 0, 10 over 3. We get it from the value of c. Okay, And then to find the x-intercept, okay, we need to replace y equals to 0 into the equation. So when y equals to 0, x is equal to negative 10. So the coordinate of x-intercept is negative 10, 0. Okay, with these two coordinates, we can draw the graph. Okay, so we start from the origin. So x is negative 10. This is x-axis, and this is y-axis. The value for the coordinate of the y-intercept is 0, 10 over 3, which is 3.33. So the coordinate is here. Okay, so this is the y-intercept and this is x-intercept. Now we connect these 2 points with a straight line. So this is the graph of y equals to 1 over 3x plus 10 over 3. Okay, now let's move to the next example. Find the equation of straight line that's passed through point 36 and 21. Let's label this as point A and point B. Okay, let's find the coordinate of the line. Okay, we need to find M of line AB is equal to 1 minus 6 over 2 minus 3. We get negative 5 divided by negative 1, which is 5. So the slope or the gradient of this line is 5. Now, find the equation. We can use the point slope form, okay, to get the equation. Y minus y1 equals to m times x minus x1. We can find the equation by substituting the slope and also coordinate of the given point. So we have y minus y1. Let's say we take point A. So y is 6 equals to 5 times x minus 3. So we simplify this. We get y equals to 5x minus 15 plus 6. Therefore, y equals to 5x minus 9. So this is the equation. Now, to draw this, we need to find the coordinate of x-intercept and y-intercept. So, we already know y-intercept is point 0, negative 9. And for x-intercept, we substitute y equals to 0. So, we have 5x minus 9 equals to 0. Therefore, x equals to 9 over 5. Okay, with these two information, these two coordinates, 9 over 5, 0, and also 0, negative 9. Okay, we can draw the graph. Let's label the axis, x-axis and y-axis. Okay, so x is 9 over 5, which is nearly 2. And y from 0 to negative 9. So let's say we use scale by 3. Okay, so the first point is here, 0, negative 9, which is here, and also 9 over 5, the coordinate here. Okay, now connect 2 points. Don't forget to label the line. So y is equals to 5x minus 9. Let's move to example 6.7. Find the equation of line with gradient 5, which pass through point A with coordinate 3, 4. Graph the line. Okay, So we already given the slope and a coordinate of a point. So we can use point slope form of a line. So we have y minus y1 equals to m times x minus x1. Y minus y1 is 4 equals to m is 5, x minus x1 is 3. So simplify this equation, we get y equals to 5x minus 15 plus 4, which is y equals to 5x minus 11. So this is the equation of a straight line that passed through point A with gradient 5. Now let's draw the graph. Okay, from the equation, we know that the coordinate of y-intercept is 0, negative 11. So to find the coordinate of x-intercept, we substitute y equals to 0 into the equation. 5x minus 11 equals to 0. Therefore, we get x equals to 11 over 5. So the coordinate of x-intercept is 11 over 5, 0. So let's plot these 2 points. We have, we start from the origin. The x-coordinate is 2.2. So we have 1, 2, and 3. So it's before 2.5. So let's say this is the point of x-intercept. And for y-intercept is negative 11. So negative 11 is here. Now connect these 2 points with a straight line. Okay, this is the line, and don't forget to label the line. Okay, we have the equation is y equals to 5x minus 11. The distance between 2 points P and Q on a line in a rectangular coordinate system is obtained from this formula, which is derived from Pythagoras theorem. Remember this formula. Now, let's do example 6.8. Find the distance between points A and B given this coordinate. Okay. Distance between points A and B is square root difference between x component 3 minus negative 1 square plus difference between y component 4 minus 1 square. The difference between x component is 4 square, and for y component is 3 square. So we get square root of 16 plus 9, which is square root 25. Therefore, the distance between these 2 points is 5 units. Midpoint of 2 points. Consider a line segment whose endpoints are point P and point Q. The coordinates of the segment's midpoint are given by this formula. M is the midpoint equals to the sum of x component divided by 2. This represents the coordinate x coordinate, and sum of y component divided by 2. This represents the y coordinate of point M. To find the midpoint, take the average of the 2 x coordinates and the average of the 2 y coordinates. Let's do example 6.9. Find the midpoint for each line segment with the given endpoints. Okay, we have point A and point B. So the midpoint of a line from point A to point B is, the coordinate is -1 plus 2 divided by 2 and 3 plus 4 divided by 2. Therefore, we get the coordinate is 1 over 2 and 7 over 2. This is the coordinate of midpoint of a line that passed through point A. For the second midpoint from point P to Q, the midpoint is 3 plus 2 divided by 2, and for Y component is 6 plus 1 divided by 2. Therefore, the coordinate of midpoint between these 2 points is 5 over 2 and 7 over 2. Parallel and perpendicular lines. Two lines are parallel if and only if they have the same gradient, while two lines with gradient m1 and m2 are perpendicular if the product of the two gradients is equal to -1. So this is the figure of two parallel lines. M1 equals to M2. And for perpendicular lines, we can see that the product of the slope of the first line and the second line is equal to -1. So we have the intersection angle between these two lines is 90 degrees. Let's discuss example 6.10. Given point A, B, C, D, E, F, G, and H with their coordinates, draw lines AB, CD, EF, and GH. Alright, so first we settle this one. Let's draw the lines. Okay, before we draw the lines, let's plot the points. Okay, so before we plot the points, we need to write the scale. Point A is -2, -3, which is -2 and -3 is here. Label A. Point B is 4, 6. Label the point. Point C is -4, 2. Point D is 0, 8. This is point D. Point E is -2, 3. This is point E. Point F is 1, 7. F. Point G is 2, 4. This is G. And point H is 6, 1. H. Okay, now we need to connect these points to get lines AB, CD, EF, and GH. This is line AB. This is line CD. This is EF. And this is line GH. Next, we need to show which lines are parallel and perpendicular. Okay, to know which line are parallel or perpendicular, we need to find the slope for each line. Okay, let's do this. These are the slopes for each line. Okay, from the slope, we can see that lines AB and CD has the same slope, which is 3 over 2. Therefore, we can say that AB is parallel with CD. How about the perpendicular? So let's check between line GH and CD. If we get the product of the two slope is equal to -1, therefore these two lines are perpendicular. So we have MCD dot or multiply with gradient of line GH. So CD is 3/2 times -3/4. Can we get -1? No. So because we get -9/8, which is not equals to -1. Okay, therefore we can say that CD is not perpendicular with GH. Also, AB is not perpendicular to line GH. Okay, now let's check between EF and GH. Slope of GH times slope of line EF. So we have -3/4 times 4/3. We get -1. Therefore, from this result, we can say that line GH perpendicular with EF.
Okay, now let's discuss example 6.11. Find the equation of the line L1, which is through point 13 and perpendicular to the line 2x plus 3y equals to 12. Next, find the equation of the line L2, which is through point 45, coordinate 45, and parallel to line L1. Okay, in this question, we need to find two equations. One is equation of line L1, and then another one is for L2. Okay, let's do one by one. First, we need to find this equation, which is pass through point 13 and perpendicular to the line 2x plus 3y equals to 12. To get the first equation, we need to rearrange the given equation, the given line. Okay, we have 2x plus 3y equals to 12. So rearrange this, we get 3y equals to 12 minus 2x. Then we only want y on the left hand side. Therefore, we need to divide each term by 3. Therefore, we get y equals to -2/3x plus 4. From this equation, we know that the gradient of the given line is -2/3. To find the gradient of line 1 L1, we need to use this formula, which is the gradient of the given line times the gradient of L1 is equal to -1. Okay, from this formula, we get M1 is equal to -1 divided by M, which is -2/3. Now let's solve M1. And solve this, we get M1 is equal to 3/2. This is the gradient or slope of line 1. Now, we use this information, M1 equals to 3/2 and the coordinate of point 13 to get the equation of L1. By using the point slope form, y minus y1 equal to m times x minus x1. Okay, we substitute y1 from the coordinate of this point. So y minus 3 equals to m is 3/2 times x minus 1. Solve this, you will get y equals to 3/2x minus 3/2 plus 3. Therefore, y is equals to 3 over 2x plus 3 over 2. We solve this, we get 3 over 2. So this is the equation for L1. Next, to find the equation of L2, given that this line is parallel to L1, therefore, we know that the slope of L1 is also 3 over 2. By using this information and also pass through point coordinate 4, 5, okay, we can get the equation of L1. So y minus y1 equals to m times x minus x1. So y minus y1 is 5 equals to 3 over 2 times x minus 4. Solve this, we get y equals to 3 over 2x minus 6 plus 5, which gives us y equals to 3 over 2x minus 1. So this is equation of L2. Section 6.3.4 is to find the distance, the nearest distance of a point to a straight line. Okay, so we have a line and the equation is written in a general form. Ax plus by plus c is equals to 0. And we have a point, label this as point A, and the coordinate of this point is hk. So to find distance from point A to line PQ, where this line is perpendicular to line PQ. So the distance is given by this formula. So it is a modulus of AH plus BK plus C divided by square root of A squared plus B squared. This numerator is actually come from the equation. Okay, we just replace x by h. This is h, and replace y by k. Okay, now let's discuss example 6.12. Find the nearest distance from line 2 y minus 3x equals to 4 to point with coordinate 1, negative 3. So to find the distance, we need to rearrange the given line, the equation, to a general form. Ax plus by plus c equals to 0. Means we need to write all terms on the left hand side and leave 0 on the right hand side. So rearrange this equation, we get negative 3x plus 2y minus 4 equals to 0. We make sure terms with variable x is the first term, followed by term with variable y, and then terms with constant, no variable, and equals to 0. Okay, and from this equation, we can see that a is negative 3, this is a, b is 2, and c is negative 4. And from this point, this is h and k. H is negative 1 and k is negative 3. Now, to find the distance, the nearest distance, we use all this information. So, it is a ratio of negative 3 times x, we replace by h. So, times 1 plus 2 times k, which is negative 3 minus 4. This is for the numerator, and for denominator, find the square root of a square, which is negative 3 square, plus b square, 2 square, and square root. Okay, so we solve the numerator, we get negative 3 minus 6 minus 4 over square root of 9 plus 4. Don't forget the modular sign. So solve both sides, upper and bottom. So we get negative 13 over square root 13. Now, because of the modulus, the distance between from the point to the given line is 13 over square root 13. Therefore, the distance from point 1, negative 3 to this line is 13 over square root 13 unit. Okay, now for example 6.13, we need to find the nearest distance between the parallel lines y equals to x plus 6 and x equals to y plus 2. So in this example, we have two parallel lines. Okay, let's label this as L1 and L2. So this is y equals to x plus 6 and this line is x equals to y plus 2. So we use the same concept. Okay, we need to find a point on this line, the first line. And from there, we have point, for example, this is point A. And then from this point, we need to find the shortest distance. So we use the same formula. How to find the coordinate of point A? The easiest way is by letting x equals to 0. So when x equals to 0, substitute into this equation. When x equals to 0, we get y equals to 0 plus 6, which is 6. Therefore, the coordinate of point A is 0, 6. So this point lies on the line y equals to x plus 6. Okay, so this is the first step. Next, we need to find the distance from point A to line 2. Okay, to get the distance, we need to rearrange the equation of line 2. Okay, given that we have x equals to y plus 2, rearrange this, we get x minus y minus 2 equals to 0. Okay, from here, we know that A is 1, B is negative 1, and C is negative 2. Okay, next, we evaluate the distance from point A, which is 0, 6, to line L2. Okay, from here, we know that H is 0 and K is 6. Using the formula, D equals to modulus. Okay, the numerator, we use the equation of the line L2. Okay, with A is 1, B negative 1, and C negative 2. So A is 1 times x. X is replaced by 0. H, the value of H, 0 minus 1 times y, we replace by k, which is 6 minus 2, divide by a square. A is 1 square plus b square, negative 1 square. So, and square root. Therefore, we calculate this. Numerator is negative 8 divided by square root. 1 square is 1 plus negative 1 square also 1. So 1 plus 1 is 2, square root 2. Okay, now the final distance. Okay, the nearest distance from point A on line L1 to line L2 is 8 over square root 2 units. So this is the answer. Last subsection in chapter 6 is straight lines intersection. An intersection of the two straight lines can be found by solving both equations together or simultaneously. Okay. Let's refer to example 6.14. Okay. Find the intersection of the two straight lines. Okay, this is line 1 and line 2. So, we need to find the coordinate of intersection between these two lines. Okay, let's label the first line as first equation and second L2 as equation 2. Okay, from here we can see that we can have same coefficient of variable x. To get same coefficient of variable x, we multiply equation 2 by 6. So 6 times equation 2 give us 6x plus 12y equals to 24. Let's label this as equation 3. Now, we have equation 1 and equation 3. To eliminate x, we subtract equation 3 from equation 1. So, equation 1 minus equation 3. So, now we have 6x minus 6x give us 0x. Then, 5y minus 12y give us negative 7y and then equal to 6 minus 24, which is negative 18. Solve this, we get negative 7y equals to negative 18. Therefore, y is equals to 18 over 7. This is value for y. Now, we need to get the value for x. Okay, so to get x, we substitute y equals to 18 over 7 into either equation. Let's substitute y into equation 2. So, we get x plus 2 times 18 over 7 equals to 4. Therefore, x equals to 4 minus 2 times 18 is 36 over 7. Give us negative 8 over 7. So, these values x and y represent the x and y component of the intersection point. Therefore, the intersection point is negative 8 over 7 and y is 18 over 7. So, this is the coordinate of the intersection point. Okay, that's all for now. Thank you.